Okay, everyone, let's take a look at Chapter 1 in Electrical Motor Controls. This will be electrical quantities and basic circuits. In an atom, electrons orbit the nucleus in shells that can hold a specific number of electrons. A conductor allows free electrons to pass readily through it. Electrons in a conductor atom are held to the atom with minimal force. Electrons in an insulator atom are held to the atom with a relatively strong force and cannot be moved very easily. Non-metallic sheave cable is manufactured in various wire sizes and with a specified number of conductors. Printed circuit boards have conductors laminated on an insulated material that makes up the board. Semiconductors are made from materials that have 4 valence electrons. Current flows from negative potential to positive potential and is assisted by free electrons when voltage is applied to N-type material. When voltage is applied to P-type material, the holes are filled with free electrons that move from the negative potential to the positive potential through the crystal. In a diode, P-type and N-type materials exchange carriers at the junction of the two materials, creating a depletion region. Forward bias electrons flow from cathode to anode, but in reverse bias electrons do not flow. Manufacturers use a variety of methods to indicate the cathode end of a diode. The forms of energy used to produce electricity include coal, nuclear power, natural gas, and oil. Electrical energy is used to produce motion, light, heat, sound, and visual outputs. Voltage is produced by electromagnetism, heat, light, chemical reaction, pressure, and friction. DC voltage is produced from batteries, photovoltaic cells, and rectified AC voltage supplies, and can vary from almost pure DC voltage to half-wave DC voltage. AC voltage has one positive alteration and one negative alteration per cycle and is either single-phase or three-phase. The amount of current a cell or battery can supply depends on the cell or battery size. The smaller the AWG number, the greater the cross-sectional area and the heavier the wire. Abbreviations are used to simplify the expression of common electrical terms and quantities. Ohm's law is the relationship between voltage, current, and resistance in a circuit. This will be section 1.2, circuits. A series connection has 2 or more components connected so there is only one path for current flow. A parallel connection has 2 or more components connected so there is more than one path for current flow. A series parallel connection is a combination of series and parallel connected components. Principles of series and parallel circuits can be used to produce several different heat outputs in heating element circuits. Photovoltaic cells are placed in series to increase the voltage output from a set of photovoltaic cells. Photovoltaic cells are placed in parallel to increase the current output from a set of photovoltaic cells. Be section 1.3, magnetism. The molecular theory of magnetism states that all substances are made up of a number of molecular magnets can be arranged in either an organized or disorganized manner. In 1819, the Danish physicist Hans C. Ørsted discovered that a magnetic field is created around an electrical conductor when electrical current flows through the conductor. The lines of force or lines of induction are present along the full length of the conductor. The total number of lines of force are Maxwell's, and 1 square centimeter section of a magnetic field equals the flux density of the field, or the Gauss. If a conductor is formed into a coil, the lines of force combine, forming a stronger field than the lines of force from a single loop. The strength of a magnetic field produced by a conductor may be increased by increasing the voltage, increasing the number of coils, or inserting an iron core through the coil. A conductor formed into a coil produces a strong magnetic field around the coil when current flows through the coil. Phase shift occurs when voltage and current in an AC circuit do not reach their maximum amplitude and a zero level simultaneously. Capacitors are available in different sizes and shapes. With a charged capacitor, the electron orbits become stretched towards the positively charged plate. Current leads voltage in an AC capacitive circuit. An elastic diagram in water can be used to represent the internal action of a capacitor. The current flowing in an inductive AC circuit is directly proportional to the applied voltage and inversely proportional to the inductive reactance. Capacitive reactance is inversely proportional to the capacitance and the frequency. This will be section 1.4, power. Power formula is the relationship between power, voltage, and current in an electrical circuit. True power is always less than apparent power in a circuit with a phase shift between voltage and current. A running capacitor can be added to a motor to achieve a power factor of 1.0 and 100% efficiency. Ohm's law can be used on circuits with impedance by substituting Z for impedance and R for resistance in the formula. Alright everyone, that was it for that session. Next one will be chapter 2, symbols and diagrams. See you over there.